Good morning, students. I hope this video finds you good and you can go through this video and it will be really helpful for you all. So you have a paper on Wednesday, everybody knows that. And please be prepared, just go through the EOT. I hope a lot of things come from the EOT and it will be easier and good for you all. So I've already shared the screen. So I'll just again share the screen and we can start with our first question here. Okay, so this is the EOT for the 2020, 2024, 2025 for term one. Okay, and let us go quickly over this. There are two parts here. Okay, first is about the pendulum. I hope everybody knows what a pendulum is about. Pendulum, simple pendulum consists of a massive object called bob suspended by the string. Okay, and in the regular course, I have talked about the time period also, right? So how to find the time period, and that will coming up in the next thing. The suspended by the ring, that is the rod length L, and the bob swings back and forth. The strong and there's a tension, there's a force of tension and gravity also X. So gravity X is the downward force and the tension X always in the opposite direction. I hope you know that. Okay, so this is the basic um, you can say the definition for the pendulum, right, guys? So of course, you know this. Okay, this is so to find the period of pendulum, this is a very, very important kanun here. T equals to 2 pi root L upon G, where pi is a constant, L is the length of the pendulum, and G is the gravity. Okay, so if you use this formula, you will get the period of pendulum. Okay, so we have a question here. What is the period of Earth on the pendulum with the length 1 meter? So you will just substitute the values and you don't have to do anything. You can just practically put all the values in the calculator and you get the answer. So this answer is 2 seconds. The second one, they're asking how long was the pendulum be on the moon when the G is 1.6 Newton per kg and to have a period of 2 seconds. So period is given 2 seconds and then you can get this. Okay, so here also the formula is given T equals to 2 pi root L upon G. Straight away, you're going to just put the values in the kanun in the formula and get the sum. On certain planet, the period is 0.75 meter long period at 1.8 second. What is the G? So you have to find G over here. So in the first you're finding T, the second you're finding L, you're finding G. So according to the like the equation how you solve, you are just going to uh, uh, get the unknown on one side and you can do it, right? Okay. How much will the length of the pendulum be doubled if this is very important. How much the length of the pendulum will change double to double its period? How much the length will change to half the period? Okay. So T will be 2T. So this is before T equals to 2 pi root L1 upon G1. We have to change. Okay. And thus after it will be 2 pi L2 upon G2. So this they are saying this is the equation one, this is the equation two. We're saying how much the length of a pendulum will change to double its period. Okay, so to double its period, T becomes 2T. Okay, T becomes 2T. So this is root. So 1 upon 2 half square. See, can you see this? 1 upon 2 is very simple and very nicely given. 1 upon 2 half square equal to root L1 upon L2, the whole bracket square. So it becomes 4. So the new length should be 4 times L1. Okay, if you want to double the period of pendulum, so the new length should be 4 times L1. Okay, and how much with the length? So if you want the half period, so you'll make it T by 2. So the new length should be L2 will be 1/4 L1. Very nicely given. It will be 1/4 L1. Clear? So you before will be always the basic formula T equals to 2 pi root L1 upon G, and after it will be T by 2 because you're changing the time period from T to T2 and from here T to 2T. So you're very nicely and very clearly given over here in the PPT here. Next, Hooke's law, everybody knows F equals to minus KX. Okay. So F and KX, you can make this kind of a triangle and you can solve it. Okay. And next is the potential energy is given by half KX square. Newton meter. This all you have done very nicely in the test also formatives. So these are the sums. What is the swing constant of the swing that stretches 12 centimeter when an object is weighing 24 Newton? So F equal to minus K. So 24 equals to minus kx minus k into minus 0.12. You solve this. K will be 200 Newton per meter. Next, V will be half kx square, half into 144 into 0.165. Just you have to just apply the formula, guys. Just applying the formula, whatever is given to you, you should try to understand. Whenever you get 56 like Newton per meter, so Newton per meter is a unit for K. You should understand that. Okay, Newton per meter is a unit for K. That is a constant. Force you'll get by Newton, and X will be given by meters or centimeters. And fourth P equal to half kx square, even this is given to you. Nicely, nothing to worry about. Superposition of the wave, you know, okay. Principle of superposition of the wave is very important. Wave boundary, incident ray, reflected ray, when they are in the opposite direction, okay, when they're in the opposite direction, they nullify. So this is the case. So when they're in the opposite direction, but both crest is coming, it will be more, okay, uh, it will be +4, and when they're in the opposite direction, it will be, they will nullify. There you can get nodes there. Okay, you'll get node. So this is there. So the result superposition of two waves is basically called as interference. Okay, this destructive, you know the destructive interference. Basically the nodes. This is the constructive interference, and these are different amplitudes. Okay, node and antinode. I hope you clear. Node is a 0 point, and antinode is a maximum point. See, look here. Very nicely given. These are N and this is A. Sketch two waves. So this is the two waves we can sketch. Okay, showing greater. So it should be antinodes here. Mechanical wave, transfer wave, mechanical wave, periodic wave, longitudinal wave. Longitudinal wave is for the sound. Mechanical wave are basically the combination of transverse and the longitudinal. Transverse wave also, you know, wave pulse, you know. So everything is clear over here also. This is the basic thing what we have started with it. Next, surface wave is something very important, guys. Okay, so surface wave is a mixture of mechanical waves and the longitudinal waves. So wave that is, they're deep in the motion. So they are having translatory and rotationary motion both. Can you see the crest and trough? Deep lake ocean is longitudinal. In surface wave, however, the median particle follow a circular path, that is direction of the wave travel. As shown in the figure, surface wave sets particle in the medium. In case water in circular pattern, at the top and the bottom of the circular part, the particles are moving parallel to the direction of the wave travel. This is similar to the longitudinal wave at the left and the right side of the each circle. See, this way. So it's clearly mentioned in the diagram. You can do it. Transfer wave, suppose you and your lab partner are asked to demonstrate. Remember one thing, how could you do it? See, in between, if you're shaking it, this loop what you're attached, this loop will not move. If the loop is not moving, that shows the energy is not being transferred, only it is forming wave. Okay, so you can say loosely tie a piece of yarn somewhere near the middle of the rope with your partner holding one end of the rope. Shake the other end and down to create a transfer wave. Note that while the wave moves down the rope, the yarn move up and down but stays in the same place. Okay, wave characteristics. This is very important. Amplitude does not change. Wavelength increases or decreases. Velocity does not change. Amplitude and frequency time period. Amplitude and velocity remains unchanged. Amplitude velocity remains unchanged, but the frequency increases while the period of the wavelength decreases. Frequency will increase, wavelength will be decreasing, and also the time will be decreasing, because you know the formula F and T are inversely proportional. F equals to 1 by T. I hope you know that. Okay. So here describe longitudinal wave. What about the medium transmits longitudinal wave? So definitely you need a medium here. You need a medium. That is very much clear over here, right? You need a medium. That's not a problem. Okay. So you can do this. Perceiving sound. For perceiving sound, you have highness or loudness of the sound. Okay. That is the loudness is basically the amplitude, and the pitch is the frequency. What physical characteristics of the sound wave change the pitch? Pitch, frequency, loudness will be amplitude. Remember that pitch, frequency, loudness, amplitude. Okay, this is a human scale. Sound level and decibel. Decibel is the unit for the sound level. So 20 decibel. Faintest sound is 0. Sound that is 10 times more intense register is 20 decibel. A sound that is another 10 times will be 40 decibel. Remember that. Okay, I'll tell you how to do the sums on this because you definitely get sums on these types. Okay. Long exposure to 100 decibel, okay, or greater, it can produce a permanent damage. Earplugs reduce the sound level only by 10 decibels. Special ears inserts 25 decibel reduction. Specifically designed earpuffs and inserts can reduce the sound level by 45 decibels also. Sources of sound, mouthpiece or ear, reed. Okay, string instrument, loudspeaker, human voice. Everybody knows over that how does it work, and we have done. The string instruments are piano, guitar, violin. Working setup, loudspeaker are the electrical gadgets, and human voice produced by the vibration of the vocal cords. Okay. Okay. Sources of sound: brass instrument, reed instrument, air instrument. Brass instruments are trumpet, tuba, bugle. The lips for the performer vibrates. Reed instruments are clarinet, saxophone. Okay. Air instruments are flute and the organ pipe. Piano wire are struck, guitar wires are plucked, violin friction or bow causes the string to vibrate. These are the string instruments. Loudspeaker, they have cone that is made up of vibrate electrical currents. Vibrating surface, gong, cymbal, drums. Human voice produce vocal cords. Resonance. Resonance is something very important. Okay. What is resonance? Resonating substance, you know, right? You have a natural frequency, and suppose if you have some force vibrations, so when the force vibration matches the natural frequency, a loud sound is being produced. Okay, loud sound is being produced, so it increases the amplitude. So that is called a resonance. As the tube is raised all over, the length of the air column changes, which causes the sound volume to change. So basically about the resonance, which you have already done. Open pipe resonators, closed pipe resonators, this we have already done. In here, you have to remember one thing: high pressure reflects as a high pressure, and in closed pipe, in open pipe, high pressure reflects as a low pressure. That you should understand. Okay, these are the formulas which we have already done. Many a time we have done it in the um, in the class. Closed pipe 1/4, 3/4, 5/4. Open pipe will be 1/2. Yeah. This is for all the numbers 1, 2, 3, 4. Open pipe will be consecutive numbers. Closed pipe will be alternate numbers, even odd numbers, 1, 3, 5, 7, like that. This is the formula. This formula will be given to you in the paper. Don't worry, okay? 1/4, 1/4, what the height is 5/4. Remember that. See how it is given. 1, 1, 2, 3, 4, 5. So 1/4, 1/4, so 5/4 is given to you. Closed pipe. This is open pipe. This is 1, 2, and 3. It's just a single pipe. Yeah. You got how 3/4, how 5/4? It is nicely given. Okay, it's I think in the PPT already. How five parts are coming? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And how you have 3 parts over here. Open pipe, it is half lambda. Closed pipe, it is 1/4 lambda. Just remember that. Okay. Open pipe is 1/2 lambda. Closed pipe is 1/4 lambda. Again, these are the formulas which is already been given in the textbook directly. You should just know to utilize them. Open pipe string Cn equals to 5. Then how you do it? Antinodes, nodes, the length. Look here, 1, 2, 3, 4, 5. There are 1, 2, 3, 4, 5 antinodes. 1, 2, 3, 4, 5, 6 nodes. Okay. So nodes will be always 1, and towards the nodes will be always 1. But we just add 1 to it, okay? And then everything is given. This is for the closed pipe. The closed pipe antinodes and nodes will be same. You see here? For the open pipe, your node is 1 greater than your antinode. The closed pipe both are same. So accordingly, you will take the formula. Formulas will be given there. Resonance. Resonance we have already spoken about. Look here, n is 1, 2, 3. 3 ways. 1, 2, 3. 1. This is 1, 3. 1, 2, 3. And this is 1, 2, 1, 2, 3, 4, and 5. This was the cutting I have done, right? This is for the string, open pipe, and closed pipe. Remember one thing, string, it is 1, 2, 3, open pipe 1, 2, 3, closed pipe, it is 1, 3, and 5. Okay, this also if you do now, it will be very easier for you. It will be very clear for you all. Yeah, guys. Let's go ahead now. Okay, a 440 tuning fork is used to resonating column to determine velocity of the sound of the helium gas with the spacing between them. Spacing is given to you. That is, spacing is given by the formula L2 minus L1. L2 minus L1, that is lambda by 2. Okay, so L2 minus L1 is lambda by 2. So this we are going to take 110 upon 100 will become 1.1 meter. 1.1 equal to lambda 2. So your lambda will be 2.2 meters. Once you get the lambda, V equals to wavelength into frequency, 2.2 into 440, 9.68 meter per second. Here the frequency of the tuning fork is unknown. The student uses an air column 27 and find resonance stage 20.2. What is the frequency of the tuning fork? So spacing lambda by 2, 0.202 lambda by 2, that is 0.404 m meters. Frequency is velocity is 347. V equals to lambda f 347 equals to 0.407. F equal to 859 hertz. A pipe tuning fork is held close above close pipe. Find the spacing between the resonance. The spacing they are asking. F is given 440, V is 343, lambda they are asking. So same formula, V equal to lambda f 343 equal to lambda of into 440. You divide this and then you can get the spacing. Remember, guys, for spacing the formula is lambda by 2. Okay, that is L2 minus L1. That is the spacing formula. A Google can be bought 2 and 1. These all are textbook sum which we have already solved. Okay, many a time we have solved this. This also you can go through this by the normal method. Okay, a Google can be thought of an open pipe. If the Google was straightened out, it would be 2.65 meters long. Okay, so your length is 2.65 meters long. V is given. Then F equal to NV upon 2L, the formula 64.7. This is the first formula. For F2, multiply this 2 into F1. Okay, 2 into F1. And for third, it will 3 into F1. Sound quality. Sound quality is basically the tuning is sound quality is fundamental and the harmonics. Okay, I hope you know what is the fundamental, what is the harmonic. Okay, harmonics are the different frequencies. The further frequency. Fundamental is the base. The lowest frequency of a sound that resonates is called fundamental. A closed pipe with resonance is called a wide number of multiple fundamental frequencies are called harmonics. Tuning for clarinet, okay? A pure sound produced by the tuning fork is represented by simple sine wave. The more complex sound produced by the clarinet is represented by the bottom graph. So sound quality basically is the timbre. Many a times I've told you, right? Because if you have the same amplitude, you have the same frequency, okay, but still the sound coming from the guitars, sound coming from the drums are different. So it is different because of the timbre. It is different because of the timbre. So remember that. So timbre suggests or timbre tells you about the sound quality. Consonant and dissonant, when two different pitches are played at the same time. Okay, consonance is something, dissonance is an unpleasant set of pitches. All like a noise is called a dissonance. Consonance is a melodious as a good sound which is pleasing to your ears. These are the instruments. This is the same thing what we have done. Okay, beat. There's a very yeah important this question they ask. Find the beat frequency. So beat frequency will be FF and FB. What is FA? F is wave 1 and FB is wave 2. So difference between the wave will call you, it will be a beat frequency. Okay. Very simple. Beat frequency sum will be definitely coming. Okay. Timbre. Why do various instruments sound different even when they play the same note? Because each instrument produces their own set of fundamental harmonic, so they have a different timbres. Okay, conductor insulators, everybody knows this, guys. Okay, air is a insulator. Okay, conductors you can see plus minus everywhere, insulator plus minus at one end only. Diagram is given everything. Charge, type of charge is charge separation, everybody knows this, right? Type of charge is positive, negative charge separation. We can give a rubber rod, a negatively rod by rubbing the rod. What happens to the charge of the wool? Okay. After you rub a comb on the wool sweater, you can use the comb to pick up the small pieces because what when the comb loses its negative charge to its surrounding and become neutral once again. Type of charge pitball is a small sphere made of light material, such as plastic foam, that is often coated with a layer of graphite or aluminum paint. How could you determine whether a pitball is suspended from any insulating thread is neutral and charged positively or charged negatively? So here is the answer for this. Bring an open, bring an object of a known charge, such as negatively charged hard rubber rod near the pitball. If the pitball is repelled, it is the same charge on the rod. If it is attracted, it may the opposite charge or to be neutral. To find out which brings a positively charged glass rod near the pitball, if they repel, the pitball is positive, if they attract. The pitball must be neutral, they are saying. Okay. Next, a charge separation. You can give a rubber rod a negatively charged by rubbing the rubber with the wool. What happens to the charge of the wool and why? The wool becomes positively charged because it gives up electron to the rubber rod. Okay, this is the electric potential. Very nicely in the diagram, everything is explained. Just go through it. Another formula which is coming, E equals to KQ upon R square. Okay, K is a constant, Q is a charge, R is a distance. V equals to ED. This is another formula. This you should remember. V is for the volt, E is for the electric field, and D is for the distance. The unit of volt is V. The unit of electric field is Newton per coulomb, and D distance is meters. Okay, here are the sums. Very simple. They are just application of formula. The electric field intensity between two large charged parallel plates is 6000 N per C. The plates are 0.05 meters apart. What is the electric potential? So V equals to ED. 6000 into 0.05, 300 volt. This is given to you. So simple. There's nothing you have to do. Okay. A voltmeter is 400 volt across two charged parallel plates that are 0.02 meters apart. What is the magnitude of the electric field between them? Okay, V equals to ED. So 400 equals to E into 0.02. E will be 20,000. Next, what electric potential difference is between the metal plates? So here basically, one thing will be given and other thing you have to just one unknown will be given to you. Okay, one unknown will be given to you, and the other unknown you just have to just find. Take Bachchan ki I Want to Talk film release हुई है. श्वेता Okay, when you apply a potential difference of 125 volt between two parallel plates, the field between them is 4.25 10 raised to 3 Newton Coulomb. How far apart are the plates? So how far apart? D they are asking. So V equals to ED. V is given to you, E is given to you, just get D. Straight formula. This is also the same thing. You apply potential difference of 275 volt between two parallel plates that are 0.35 centimeter. Remember, it's 0.35 centimeter. We need to change the centimeter. Okay, you need to change the centimeter into meter. How large is the electric field between the plates? You just need to change that. What work is done? Okay, now work done. You have a formula V equals to W upon Q. W equals to 1.5 into 3. You will multiply 4.5 joules, right? What a magnitude of the electric field between the two plates shown here? 2.4 centimeters. So that will become 0.02 meters. So V equals to ED. Again, the same thing. An electron passing V equals to W upon Q. This all formulas and all we have already given. I have made a set of formulas also. Just go through it and clear it. Accordingly, you can do it. So 18,000 equal to W upon 1.6 into 10 raised to minus 19. Just multiply and get the sum. Get the answer. An electric field or particle accelerator has this much. This is E is given to you. How much work is done for the proton to move? So work done is W equals to V only. So V equals to ED. You solve this and you get the answer. So V equals to W upon Q. Next, V equals to W upon Q here. A 12 volt battery, our battery is 144 into 10 raised to 6 usable. How about what can be battery before it energized? So V equals to W upon Q. V del equal to W upon 1.44 into 10 raised to 6. We'll start with the second part. MCQ question. Coulomb's law, guys. Coulomb's law. F equal to K, Q1, Q2 upon R square. Everybody knows that. Okay. So F increases, Q1 also increases, decreases. F2 increases. F and Q1 and Q2 charges are directly proportional to each other. Remember that. Okay. And distance is inversely proportional 1 upon R square. 1 upon R square. Huh? Means force and distance are inversely proportional in the square. You take the square term. For example, the distance is increased by 3 times. So force will decrease by, okay, uh, uh, yeah, the force between them will decrease by 1 upon 9 times. If you are increasing the distance, so force will be increasing the distance, the force will be, yeah, inversely proportional. It will be less. Or suppose increasing the distance, force will be less. If you are decreasing the distance, then the force will be more that way. This also we have done Coulomb's law, F equal to K Q1 Q2 upon R square. This Kanun will be given in the paper. So nothing to worry over here. Vector quantity because it has got a direction. And this is very important. How are the electrostatic force between and distance related? How would the force change if the distance between two charges are triple? Okay. So if they're triple, so force will decrease by 9 times. This way you will put it. Because F is inversely proportional to 1 upon R square. Okay. Okay, you have this. Electrostatic force, you have two charges spheres of held R. Compare the forces sphere of A on B with the force of B on A. So of course, it will be an opposite charge. Here also they are giving the same thing. See, here basically they are comparing the gravitational law of Newton with this Coulomb's law. Okay, so equal to G M1 M2 upon R R12 square K Q1 Q2 upon R12 square. So they are equating. So you get this formula. And how it is coming in also, it's nicely given to you. Okay, now your negative charge of 2 into 10 raised to minus 4, positive charge 8 into 10 raised to 3 are separated by 0.3 meters. So same thing, what is the force? So all the things are given to you, get the answer. There also K and Q1, Q2 is given. You have to find Q here. Force is given to you, K is given to you, Q1 is given, R is given. You know, you can just make this as a known and you can use this. Cool. These are the textual sums funny guys. I hope you know this. Okay, here this is a little something you have to understand. There you have to take the net force. If the asking the net force is basically the root F upon V, and so square root of F BA square plus AB square, you know that thing you have to do it. You get the square root here. That's it. You need to take the square root. And for getting the angle theta, tan theta will be horizontal upon vertical. Suppose you replace the change charge on V, this so microcoulomb will become 10 raised to minus 6. This is how electricity flow between the two charges when the distance between these charges are tripled. Okay, so this it will reduce by 9 times. It will decrease by the factor 3 square, that is 9 times. This was a sphere located, two spheres are located at a particular point. Determine the net force. For net force, finally you have to get the net force, okay? So it's nicely given here. Okay, this is electric field near the conductors. Conducting sphere, hollow sphere, you have this, right? On conducting sphere, the charge is evenly distributed. On hollow sphere, entirely outer surface, okay? There's one more which is, yeah. Irregular surface, it will be at one side. Okay, that's nice. The capacitance is C equals to Q upon delta V. So this is C 5.3 into 10 raised to 11. Q upon 12. This also we have, right? Okay, the capacitance is a new formula. This also you have to remember. Probably this will be given in the paper or not, I'm not sure, but you should know this Karun. Capacitance Q equals to C equals to Q upon V. And I hope you know what is the capacitance. Capacitance is basically is the ratio of the magnet or the net charge, how much you can store, okay, on a plate of the capacitor or with the potential difference. That way they are saying. Millikan oil drop is also clear, I hope. In this thing, the electric field should be equal to the Fg, the force, the gravitational field. Electric field should be equal to gravitational field that they are saying here. That's it. Yeah, yeah. These are the textual questions only printed it directly. Fg equal to Fu you can do, and then you can equate with this. Fg is given, but you can equate to Fe and get the form answer equal to Fe upon G. This is very important here. If you want to find the number of electrons, guys, see here. 1 is for 1.6 into 10 raised to minus 19. So 3.2, how many electrons? So it will be 2 electrons. Very simple. Just you need to divide them. And out of carries 1 excess electron from weighing 6.4. What electric field does you need to suspend the drop so it is motion there? F equal to Fe, E equal to Fe upon 9. Q. Get the answer 40,000 Newton per coulomb. This is the same thing here. This is the same thing here. Same formulas are coming. Same E equal to Fe upon Q, E equal to V upon D. Same thing. So see, this is the main formula. Capacitance C equals to Q upon V. C is the farad, Q is the coulomb, and V is the volt. They have done everything in the class. Here there's a catch. 27 microfarad. Microfarad is there. From microfarad, you will make it 10 raised to minus 6. Okay, so 27, you have to make it 27 into 10 raised to minus 6. Guys, remember this, okay? If you have microfarad, you cannot use microfarad. You'll get it wrong. The answer will be wrong. You have to convert it into farad. You cannot work with microfarad, right? Suppose this is also given. Then suppose you connect both 3.3 microfarad and 6.8 microfarad capacitor across 24 electric potential difference. What capacitors has the net charge force? So Q equals C equals to Q upon delta V, then Q2 upon delta V here also, and then you can just get this. You identify the magnitude of the net charge on the which 3.5, which capacitor has the larger potential difference across the, or what is the potential difference you can say. So C equals to Q upon V or C2 equals to Q upon V2. So this V equals to 106 and 51. And 60 also is the same thing. See, two things are given, and out of that, one thing you have to just take it. That's it. This is sphere. This is also the solved one. C equals to Q by V. Same thing. Same formula. And all is very simple. C equal to Q by V. You just have to put you can say the values, and accordingly you have to just do the sums. One unknown will be given, others will be known to you. Wave property, this is clear. Wavelength, right? Phase, period, everything. This we have already covered up. F equal to 1 by T, lambda equal to V by, yeah. F. Lambda is meters, V is meter per second, hertz is, sorry, frequency is hertz. You are clear with this. Graphing waves. A sound wave produced by the cloud church is 5.5 meter away, 1.5 meters. So V equals to D upon T. So 5.5 divided by 1.5, that is 343. Then the time 1 upon F, lambda will be V upon F, or V equal to F lambda. So the formulas are given to you. Accordingly, you will do it. How are the wavelength, frequency, speed of the wave related? How they are dependent? Wavelength, how they related means you will definitely give the formula to each other. Formula is right. What is the speed of the periodic wave disturbance of 350 hertz and wavelength 0.7? We go to F lambda, same thing. How does increasing the wavelength by 50% affect the frequency of the wave on a rope? How does increase the wave by 50%? So see, before it is and after it will be 1.5 times. So this is given here, right? 50%. So 50%, 50 upon 100. So basically it will be 1 plus 1 upon 2 times, 50% affect the, so 2 by 3. 2 by 3 you can do, or you can do some other ways also. But this is a good way. The speed of the transfer wave is given to you. The source disturbance is 6. What is the wavelength? Same formula, same here also. We go to lambda f will be under the formula. Why lambda f? Because f we are replacing by 1 by t. Okay. So this f you can find 1 by t and then you can put here. That we also can do. F equal to 1 by t. There is the direct formula, lambda f. How does the frequency of the wave change when the period of the wave is double? F equal to 1 by t, f equal to 1 upon 2t. So F2 equal to half F1. Because the charge change in the wavelength of the wave when the period is reduced by 1/2. So C. So time from t becomes t by 2. This is before, this is before, this is after. Clearly, it is nicely given here. If the speed of the wave increases by 1.5 times its original speed while frequency remains constant, how does the wavelength change here? Wavelength also increases by 1.5. Resonance we have done already. Pitch also, is the shrillness, the highness or the loudness, the highness or the lowness of the sound. Sources of sound, mouthpiece, brass instrument, wooden instrument. Resonance, this we have already done it. Open pipe, this is already covered up. It's the same thing. So I'm just going through quickly because this already we have done. There's nothing new. Doppler's effect is something different. I hope the Doppler effect you know. The change in the frequency of the sound caused by the movement of either the source detector or both is called a Doppler effect. This is a Kanun. Everybody knows FD, FD, FE, the frequency of the object observer. F is the frequency of the source, Fs. Vs is the velocity of the source. Vd is the velocity of the observer, right? V is the velocity of the light. For sound and light, see, come closer. Come closer, frequency increases, go away, frequency decreases. Light, blue shift. Frequency increases and here frequency decreases, same thing. This is a point given here. Try to understand, nicely given. What is given the red? You do this. Okay, this is the connecting law. Everybody knows that. Your position, when you have to take minus and when you have to take it negative. Okay, source is coming towards the object, positive. Going away, negative. So these are the sums. Everything is given to you. You should understand You should understand this, like basically the convertible 24.6 traveling, so it will be minus. Okay, it will just minus. So plus into minus will become convert. So it is 24.6 only. Okay, 24, but it is positive only. But the car moving away. So if the source moving away, you will take it minus. If the source is coming, it will be plus. Traveling while traveling a convertible 24.6, the car is towards you. If the source is coming towards you, it is plus only. Or if the car is going away, then it will be minus. Okay. So here your 24.6 becomes minus here. Did you get it? Look here. So the frequency changes for the second sum in this problem one, what is been depended upon first here. But the car moving away from you. This was on the same lines. You should understand where to take what, like, or when this we have done quite a lot. I've given lots of worksheets on this Doppler effect. I think the Doppler effect is clear to you all. So somebody going towards another submarine 9.20 it ms. So here the a very good way of writing and everything is given here, so that you can go through them properly. Wave characteristic graph, effect of medium, decibel. Decibel scale you have to remember. This is something very, very important question will be coming. How many times greater is the sound pressure level of a typical rock concert to 110 and normal conversation 50? So first what you'll do, suppose you have 50 minus 70, that is into 10, 70 minus 90 into 10. Whatever difference you have, no? Suppose 110 and 50. So the difference is 60. So 60 will multiply by 10. Okay. So it will be 1000 times, 10, 10, 10. So 1000 times. So see, it is 60, na? So 60 you will multiply by the three zeros, because there are how many 20 20s every difference of 20, na? See, the sound pressure level increases by factor of 10 for every 20 decibel increase sound level. Okay, so for every 20 decibel increase there's a factor by 10. So if it is 60, that means it is 10 into 10 into 10, so 1000 four times. That's clear. See, 110 and 50, the difference is almost 60 decibel, right? So for every 20, the sound level will be increasing by 10, correct? So it is 60. So it will be 10 into 10 into 10. So 1000 times. Remember that for every 20 decimal, it is 10 times. For every 40 decimal, it is 10 into 10. That is 100 times. For every 60 decimal, it will be 10 into 10 into 10. That is 1000 times that way. These sums will be coming up. All these are bat and all these all just a theoretical question which you can go through. This also we have done. Electric field also E equals to KQ upon R square. This part is also clear. This remember, negative will be always coming towards, positive will be going ahead, going away in the field strength. Definitely, because positive here is a proton, so it will be repelling each other. Here is if it's an electron negative way, it will come towards it. This we have done already. E equal to FQ, this same type of sum we have done a lot. This also the same thing. Force, intensity, field, everything is given. Just apply the formula and do it. E equals to F by Q. Same formula is applied here. This is little different. E equals to KQ upon R square. Well, distance is given, then you should use this formula, KQ upon R square. Same thing is happening. Everything is the same formula, everything of the charges. Conductor insulators concept, Forces on the charge objects also, like charges repels, unlike charges attract. electroscope charging of the by conduction. Conduction, induction, you should know it, right? Conduction is like touching. Induction is not touching. You're just getting it closer to it. In conduction, the same charge will be transferred. In induction, you can say the opposite charge comes on the near end, and the same charge comes on the further end. These are very clear over here. This type of assumption will be asking. Grounding. Grounding is very important. So the excess electrons and all, you have to remove them. So you require grounding for it. You can touch it by your fingers because your body is a good conductor of electrons. Okay, so it will take it. So grounding is important to remove the excess electrons. The type of charge separation, this all is also done. Ever contain equal number of positive and negative charge, so they are neutral. Okay. If anything is neutral, that will not show any repulsion or attraction. It's done. Fine, guys. So here we end up, and you can go through it, and wish you all the best. Okay, wish you all the best. Do well. Read the paper well. Don't get confused. Don't get panic. I know everybody will do well. Work hard. Please work hard and do all the concepts. Still, if you have any doubts, you can always ask me over the phone, or you can come to the class. I will be coming early on that day. If you want, you can come to the class here in the lab. I'll help you out if with any difficulties you want. Okay. So just be relaxed, do the paper well. Okay, guys. All the best. Wish you all the best. I hope everybody does well, and I am sure you'll do well. Okay. Yeah. Bye, guys.